Example 4 from section 5.3 is a story problem, page 329. So I'm actually going to do the example that's given as it gives the formula and everything else. So a baseball leaves a bat with an initial speed of 30 meters per second and clears a fence 90.5 meters away. The height of the fence is the same as the height of the initial height of the batted ball. If the distance the ball traveled is given by, so this is my distance, I have v sub 0 squared times the sine of 2 theta over 9.8. 9.8 is in meters per second squared. Find the interval possible, find the interval of possible launch angles of the ball. Okay, so what they're saying is if the guy hits it here to here, whatever those angles are, then the ball is going to still clear this fence that's over here. Okay, so they told us that our initial velocity is 30 meters per second and that the distance is 90.5 meters away. So I have 90.5 equals 30 squared times the sine of 2 theta over 9.8. So now this problem is going to be a little bit different than the problems that we've been doing because, number one, they're asking for the angles, okay? And so for this one, they're looking in degrees. And then these are not going to be nice numbers. So the first thing I need to do is multiply by 9.8 and then divide by 30 squared. So I can do that all on my calculator. So I can take 90.5 times 9.8 and then divided by 30 squared. So this is about 0.985. And I'm not going to use 0.985, I'm going to use the fraction that is in my calculator, the whole decimal. And I have the sine of 2 theta. So now this is different than the other problems because I have a 2 here. So I need to take the inverse sine of the number in my calculator, which is approximately 0.985. And then I have to divide by 2, okay? Now, the problem is this angle is only going to give me an angle in quadrant 1, okay? But potentially, I could have an angle in quadrant 1 or in quadrant 2, okay? So I need to find both of those. So in quadrant 1, if I do the inverse sine of my answer, and I should have changed it to degrees first. Let's try that again. I'll get the whole thing back up here. Inverse sine of my answer. Calculator's in degree mode. So I have 2 theta is about 80.2 degrees, okay? Now this is in quadrant 1, so this is my reference angle. So I'm gonna just draw a quick picture. My angle is 80.2 degrees, which means if this is also a positive sine, 80.2 degrees, in order to get this angle, I have to take 180 minus this. So my other angle is going to be about a 99.8. So if I divide that by 2, I get 49.9. And if I take this one divided by 2, I get 40.1 degrees. So there's 2 potential, this is the lower boundary and this is the upper boundary, okay? So if he hit it between 40.1 and 49.8, Is that what I got? Excuse me, 49.9. I said it right and I wrote it wrong. 49.9. If I look back on the calculator. The ball will go over the fence.